At Metalsa, we are dedicated to providing sustainable solutions for the global transportation industry, and we are proud to introduce the next generation in chassis technology. Focusing on frame innovation and technology allows us to provide customized solutions for the key players in the industry. Our team of experts set out to develop an ultralight chassis. We started the concept design in 2013, and in 2014 we built the first prototype. Meet the ultralight commercial vehicle.
The ULCV, or Ultralight Commercial Vehicle, is an initiative that Metalsa has conducted with one of its key OEM partners in North America in response to the Super Truck program, which objective is to increase freight efficiency in trucks by 50%.
Our primary goal was to build a chassis 40% lighter than the current steel baseline, without compromising its durability or stiffness, allowing us to increase the trailer payload capacity. To reach this objective, the entire architecture of the truck chassis was evaluated.
What we have done is to change the paradigm on frame construction, and we developed what we call the top and bottom concept. A top and bottom concept now uses two thinner rails positioned top and bottom versus side and side in order to provide the required section properties that we need throughout the chassis.
When aluminum is used as a core alloy, corrosion is reduced significantly. We maintain the same durability to that of current heat-treated steel frames by optimizing section properties in the design. The aluminum alloy used to produce this prototype is a formable grade developed specifically by our partner Alcoa for structural applications.
The relationship with Alcoa and Metalsa has been a strong relationship. They've been very strong to support us from the technical area. So they're not just a material supplier, but they're also a supplier and a provider of expertise in aluminum processing. This is an area that we're very new to, but they've been very helpful in developing that capability and that product that now we're starting to showcase as this next generation ultralight chassis.
The ULCV incorporates a frontal module, top and bottom side rails, and multifunctional integrated components. The largest cross-section is found towards the center of the chassis, which increases the RBM value significantly. Once the prototype was built, a full-frame fatigue test was developed to validate functionality and durability of the concept. A laboratory rig test was developed from proving ground data and employs 23 hydraulic actuators that simulate real-world inputs to the frame.
In order to perform roll load data acquisition, we needed to purchase our own truck. Once we had this truck, we retrofitted it with our concept frame, and we instrumented it with 138 sensors, which we call channels. And these channels will register the load information that is being applied to the frame. And at the proving grounds, a schedule of events was developed. These events would produce the load and displacement information necessary to input it into a full frame fatigue test.
The ULCV is the ideal choice for any bulk hauling application focused on increasing payload to improve freight efficiency, such as refuse, waste disposal, oil, or milk tankers. For example, milk is a high-value payload and a high-density liquid. It has to be transported in food-grade containers, which do not have baffle systems to minimize transient or dynamic loads. This combination of factors increases the accumulated damage on the truck chassis over time. Different road profiles found on existing milk transportation routes were replicated as test track events. Road load data was acquired by driving our instrumented truck over these surfaces in a controlled environment. In order to approximate the delivery cycle of a milk transport operation, payload configurations in the tanker were set to 0, 50, and 100% capacities. Data acquisition was also performed on a decoupled trailer state.
The events that we trialed were Burma Road, high-speed oval, railroad crossings, gravel road, launch on an incline, pothole, paved area, start and stop, and accelerations.
I'd like to take this opportunity to thank my Director of Product Innovation, Francisco Gonzalez, for not only bringing this project as far along as he has, but also the level of collaboration and the team that he's brought together. We've developed a very high level of confidence. We have a very strong rapport. But in addition to that, we've started to showcase this at key shows, such as the Mid-America Truck Show. We're also focusing on the COMVEC, or the Commercial Vehicle Engineering Congress, through SAE. We're also going to South America this year to showcase this with some of our key OEM and end users in South America. So there's a very high level of confidence that we have at Metalsa. I think one of the other things that we're developing is what we're referring to as the innovation ecosystem. This is a system where we bring in key collaborators in adjacent components and technologies. We have to move in that direction in which we develop the most synergistic and optimal solution comprising all of these key collaborators as a system. So we're looking to develop the key system as opposed to just a key frame or a key component in the chassis.
Following the excellent results obtained, the technology team can now take the next step, monitoring long-term performance in a real-world environment. We are looking for a fleet willing to deploy the ULCV for a 2-year in-field trial. This important technological advancement will break market barriers and current industry paradigms. Get to know our product and discover why so many brands rely on our world-class quality. The future has come. The future is the ultralight commercial vehicle. Better than ever. Engineered by Metalsa.